is week number 12, lecture number 12 of this course, the one before the last one. And we are going to touch upon the last topic of this course. If I position it with respect to the business process life cycle, that is the one that is guiding us throughout the course, we are going to talk about now the last but not least of the phases in that life cycle, namely the process monitoring phase. This material that I'm going to cover today is explained in much more detail in chapter 11 of the textbook that I have shared with you on Slack. The purpose of this phase of the life cycle of business process monitoring is to take data from an enterprise system where one or more business processes are being executed, and to use the data in order to analyze how the process is being performed, to understand if there are any issues or deficiencies in the process, and to be able to quantify or quantitatively assess those issues on the basis of data. So in a way, this topic is a little bit like process analysis, which we covered a few weeks ago. But in process analysis, you try to gather qualitative data from different stakeholders, and then you try to go and gather in an ad hoc manner, build up models that help you to understand those issues without looking into how the process is really executed. In business process monitoring, we take the opposite view. We take the data that is in the enterprise system, and we let the data speak. We let the data tell us what is happening in the process. What are the issues that appear to be happening on the ground? So the way this all works is that from the databases of our enterprise system, like our customer relationship management system, or our enterprise resource planning system, or our manufacturing execution system, we're going to extract certain event logs. Like we're going to see it's like files that contain where every entry corresponds to the execution of one task in the business process. We're going to extract that either by means of some scripts, extract, transform, load scripts, that are going to generate the data we need in order to analyze the process, or sometimes we are going to have the luxury of being able to receive that data in real time from event streams, we call it, coming out from the enterprise system. From those event logs that I'm going to present to you next, we can generate either performance dashboards that help us to understand the process from the perspective of its performance measures. And we are also going to generate process models and other artifacts that fall under the umbrella of something called process mining. I'm going to first talk about performance dashboards, first half of this lecture. And in the second half of the lecture, I'm going to introduce you to this set of techniques called process mining, the second part. And we're going to continue next week with the topic of process mining. So essentially, the topic we're covering this week and next week is process monitoring. And in process monitoring, there are two facets to it: performance dashboards, which we will cover first, and process mining, which we will cover next. Both of these take a starting point data about the execution of one or more process. Let us start with one process. Let me imagine I have a loan application handling process that is running in a system, let's say in the equivalent of a CRM system in a bank. From the databases of these systems where the bank records every single application for a loan that a customer has made, we can extract a data set, we call it a data frame, that captures every step in the execution of the loan application handling process. This table takes the following shape. Every row in this table, take for example the first row that is being shown here, captures something about the execution of one task in one instance of the process, one task executed for one specific loan application from one customer. In every row, in order to use it for the purpose of process monitoring, we need to know at the very least three things. We need to know what is the name of the activity that is being executed. For example, the first activity in a loan application handling process will typically be to check for the completeness of the loan application. Another one could be checking the credit history, or checking or calculating a risk score for the customer, or making a loan offer to the customer, or making a second loan offer to the customer. All these are tasks that we will execute normally in the context of such a process. And these tasks will get recorded by the system in some database, and we can then extract from that database tables that look like the one I am showing on this slide. So every row has an activity label. Secondly, every row needs to have a timestamp. When did it happen? When is it that we checked the completeness of this loan application we are talking about? That timestamp can be at the level of the date, but most often is actually at the level of the second, or the millisecond, or the microsecond even. Such timestamps can be found. Every enterprise systems out there will have every time you do something on the system, will record it in a database, and you will find such timestamps in those databases. And those timestamps are very important because they are going to be able to allow us to analyze the temporal performance of the process. How much time did it take to execute an activity? How much time did it take to execute a process, etc.? All of that will be able to get it out of those timestamps. The third thing that such tables called event logs need to have in order to be useful for process monitoring is the case identifier. And this is a little bit of a tricky one. The case identifier is an identifier that tells us in which instance of a process did this happen. So let me take, for example, the first row in this table. So the first row is telling me that check completeness as a task was executed. Fantastic. It tells me that it happened on the 18th of October of 2016. Fantastic. And then I need to say, for which loan application did we do it? Because we check the completeness of hundreds of applications every day. So we need to know this specific row to which loan application it refers. That loan application identifier, that we call it the case identifier, is the identifier of an instance of the process. In this process, which is a loan application handling process, the case identifier is the loan application ID. If you take another process, like for example, an order to cash process, the case identifier will be the purchase order number. If you take a purchase to pay process, a P2P process, the identifier will be the purchase requisition ID. In any case, every time we kind of start a process, there's always going to be some identifier that tells me about which process instance I'm talking about. That identifier gets recorded in some table in the database, and we need to go and fetch it and put it in the format of the table I am showing in this slide. And with these three attributes, we are able to retrace, if we have, for every execution of a task in the process, we have a record that has these three attributes, we have one. We have a table that retraces how every instance of the process was executed from start to end. So let me take here the loan application with ID C001, C001. That loan application was apparently created on the 18th of October. And the first thing we did was to check its completeness. And that was done by somebody. That's captured by the resource column, Sue. And that loan was for a mortgage. And that loan had a certain requested amount. That's the amount of the loan that the customer requested. At that point in time, we didn't know what was the offered amount. The second row in this table is now telling me that in the same application, C001, on the 19th of October, meaning 1 day later, we performed the check credit history task that was also done by an employee called Sue, and the loan was about a mortgage, etc., etc. The third one is telling me that, yeah, about a few hours later, maybe we calculated the risk score, and the next day, on the 20th, we make a loan offer, and a few days later, we made a second loan offer, maybe because the customer was not happy with the interest rate we gave in the first round, and he asked for a discount, and he showed us some other application that offered that he had got for the loan, so we decided to reduce a little bit the interest rate, and we made a second loan offer, actually also for a slightly higher amount. Then the next rows tell me the story of another loan application called C002, and subsequently I have C003, etc. Such tables are called event logs. An event log, to summarize, is a table that contains one row per execution of a task. And for every task, it tells us what was the task that was performed, when did it happen, and in the context of which process instance it happened. And then it has a number of other attributes, the resource, which is the name we give to the worker who performed the work, and then a number of other attributes. It doesn't really matter. Sometimes we distinguish, however, it's kind of useful sometimes to distinguish between case attributes and event attributes. The case attributes are attributes of a case, as the name indicates, of a process instance. There are attributes whose value does not change throughout the case. Like, for example, the loan goal column in this example I'm showing you, that loan goal is a case attribute. Because if you notice, for every loan, the value of that attribute is the same throughout the case. So it's mortgage, 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 right? For the first loan. And for the second one is car, 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 car purchase. It doesn't change. And for the third one is mortgage again. So it's not an attribute that changes from one event to the next. It's an attribute that belongs to the case as a whole. The same is true for the requested amount. The customer, when they put the loan application, they request a certain amount. I want to borrow 10,000 or 100,000 or 50,000. And normally that initially requested amount does not change throughout the case. Therefore, the requested amount column is a case attribute as well. On the other hand, the offered amount is an event attribute because its value changes from one event to another within the same case. So, for example, the offered amount here at the beginning of the case, of the first case of C001, is 0. So, because we have not offered the loan to this customer, and we will not offer it until later in the process. So it's 0, 0, 0, 0, or dash, 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 and then it becomes 70,000. And then next, in the second offer, we raise it from 70,000 to 80,000. So you see the value of this event went from 0 or null, 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 null. It went to 70,000 and then to 80,000. That means that this column is an event attribute. So remember, case attributes are attributes whose value do not change during a case. They remain constant. And event attributes are attributes or columns for which the value will change during the execution of a case. This is a very simplified event log. So in real life, event logs will have 30, 40, 50, 60 attributes, depending on the type of analysis. We can have even more in some cases. With this kind of event logs, there are various tools that will allow me to construct, and by the way, this was an event log of one process, but there are other processes in the organization, And for each of them, I could extract such an event log out of the enterprise system. And with all those event logs, I can do various things. One of them is to build performance dashboards. Performance dashboards are visualizations of the performance of the process in terms of indicators, charts, and tables. In a way, think about it as a bunch of charts and a bunch of tables that get calculated from the data in an event log of a business process in order to provide an overview of the performance of the process to some user. Depending on the user of a process performance dashboard, we can distinguish three types of dashboards. First one is operational dashboards, tactical dashboards, and strategic dashboards. And as we will see, each of these dashboards has a different audience. An operational dashboard is a dashboard that is used, as the name indicates, by operational managers and by workers. So an operational manager is a manager in a company that is looking into day-to-day work. So it's the person who, for example, a restaurant manager is an operational manager. He's there or she is there, trying to organize the work of today and giving instructions and taking decisions on how to handle, for example, some delays or some difficult customers out there. So they are people who are on the ground. For example, if I take this pharmacy prescription process that you are looking into in your homework, the pharmacist, in a way, is an operational manager. They are the head of the pharmacy, and they organize the work of the technicians. And they tell the technician, oh, let's do this now, let's do that now. So they are giving instructions on the ground. The process workers, also known as resources, are the people who actually do the work in the context of the process. For example, in the pharmacy information system, the technician, but also the pharmacist, are process workers. And note that a process worker, in this case a pharmacist, can also be an operational manager. So that's very typical. The person who is managing things operationally, like the restaurant manager, is sometimes also doing some work together with the other people. That gives a sense of like we are a team because I am working with you. Or in a software development team, your team leader is an operational manager. They are also like working together with the developers, to build software. So these operational managers and the process workers need to have an overview of how the process is being performed. And this overview needs to be refreshed very frequently so that they have a very good idea of where we are. Therefore, the performance dashboards that we are going to design for such operational managers and process workers, meaning the operational dashboards, are going to report things like the work in progress. How many cases are currently running, or how many cases need to be executed between now and the end of the day? What is the current workload of each resource? Meaning, if we look at our current resources, are we going to be able to complete the work of today or of this week on time, or are we going to go late? If you look, for example, at a software development process, and you take a tool for registering work in a software development process like Jira, you will see that it gives all sorts of operational dashboards with different views on, for example, how much work the developers in a team need to do between now and the end of the current iteration or the current sprint. It gives you an idea of whether things are delayed. It gives you an idea of like how much work we did today, how much work we did yesterday, how much work we are likely to do tomorrow. So it's all information about cases that are ongoing, cases that might be late, that might be delayed, and how loaded different resources in the process are. So the picture I am showing you in this slide, for example, is an operational dashboard extracted from a business process management system similar to Camunda, but this one is called Visagi, and it gives, as part of the tool, you will get dashboards that shows you, for example, how many cases among those that are currently running are on time, green, how many are late, red, and how many are at risk of being late, meaning they are close to their deadline and we have not yet completed them. And those ones are in yellow. And then it will give you some other views, like, for example, how many cases are due tomorrow, how many cases are due the day after tomorrow, etc. Those dashboards are meant for operational managers to respond to problems that are arising on a daily basis. There is another type of dashboards called tactical dashboards. And these dashboards are meant for, the tactical dashboards are not meant for the workers or the operational managers that are running the shop down there. They are meant for the managers of the operational managers, the next level of management, that wants to understand how can we improve the process? What are the general issues that we are facing in the process, in a given process, and how can we improve them? The typical user of a tactical dashboard is the so-called process owner, the manager of a process. So let me take, for example, the loan application handling process at a bank, like, for example, Swedbank. You know, the operational managers are the people who are supervising the loan assessors. So there are loan assessors, and the loan assessors have a number of assistants, and they are the operational managers. They want to know how are we doing with the loan applications that are currently being handled. Their manager, in turn, is, for example, the head of customer service or the head of lending. The head of lending, who is the process owner of the loan application handling process, you know, wants to know, you know, in general, how many customers are satisfied with the process, how many customers are dissatisfied, how many times have we been able to provide an offer to a customer in less than 1 day or 2 days, how many times it has taken us more than a week to deliver a loan to a customer. So they want to know if the process is being executed correctly and in a timely manner and in a way that is compliant with all the regulations that the bank needs to follow. So they are very interested in detecting bottlenecks. They are very interested in finding where is it that we are lacking resources, or where is it that we are failing on the client, we are not responding them on time. The typical performance indicators that these people are looking into are cycle times, what is the duration of the cases in the process, error rates, in how many process instances lead to a customer complaint, or how many process instances lead to us making a mistake during the process that we need to repair. Like, for example, making the wrong offer to the customer, or sending, you know, an incorrect number to the customer. Or the resource utilization in general. They want to know, are there some teams out there that are overloaded, and are there other teams that are underloaded? And how can we generally better distribute the work resources in the lending department of Swedbank? That's the kind of questions these people are trying to answer. And to answer those questions, they need information, for example, about the distribution of cycle times. How many loan applications are handled in less than 2 days? How many are handled in between 2 and 4 days? How many of them take between 6 and 10 days? How many take between 11 and 15 days, or 16 days and more? So that's the kind of question they want to answer. So they need charts or dashboards with charts that shows them this kind of information. Of course, in practice, this is more sophisticated. This is an extract of a tactical dashboard of a real insurance company in Australia. And it contains information for every state in Australia about the loan applications that are being handled in those different states in the past 3 months. And for each such loan, for each such state, you will be able to see how many applications are taking less than X amount of time, how many have been delivered on time, how many have been slightly late or very late, for different types of claims, by the way. So this allows the manager of this claims handling process to understand in which areas do they need to pay more attention, which areas are having problems, for example, delays in the way insurance claims are being handled, and which regions are doing much better than that. So which regions are doing well, which regions are not doing well, in order to try to direct their attention to improving the process in those geographical regions that are doing less well, or improving the process for those types of insurance claims where we are not performing very well. So the process performance, the process owner, the head of lending at Swedbank will have managers above them. Usually these managers are already at the executive level. So they are C-level managers, chief information officers, chief customer excellence managers, chief operations officers, or the CEO or the CFO above them. And these managers are called strategic managers because they are thinking about the direction of the whole organization and resolving problems at the macro level of the organization. So they are tackling challenges that the organization is having, like, for example, that the volume of loans is going down. What do we do with it? Or the general perception of the population is that the bank is underperforming in terms of customer service, meaning that the bank is doing a bad job at attending its customers. So then they get these kind of signals and they have to trigger major initiatives to try to correct on them. The type of dashboards they need are a little bit different. They are usually not interested in knowing exactly what is happening in one of the processes in the bank. They want to know what is happening across all the processes in the bank. So this here, for example, is an example of a strategic performance dashboard at a utilities company. This is like an energy company that sells you the electricity at your house. And in such a company, the strategic managers, the executive managers, will be interested in knowing how are we doing in terms of customer satisfaction, in terms of number of customer complaints, in terms of customer feedback, and in terms of service level agreement violations for different areas of the organization, for different process groups. Like, for example, how are we doing with respect to managing unplanned outages? When the electricity goes out in an entire neighborhood, how well are we doing in terms of that? How well are we doing in terms of managing our procurements? How well are we doing in terms of managing emergencies that customers call us and they have an emergency? So, and for each of them, they try to come up with indicators. So typically numbers, for example, between 0 and 1, where 1 means perfect and 0 means very poor. You probably shouldn't get there. And they want to know, in a scale of 0 to 1, how well are we doing for each of these performance areas on the left-hand side for each of the process groups at the top in the columns. And then they can highlight, like, okay, we are really having problem in terms of SLA violations in our management of outages. And we are doing very poorly in terms of customer satisfaction with respect in our procurement process. And then they will say, these are the 2 areas where we need to direct our attention. Of course, these little numbers, 0.2, 0.5, 0.8, they don't come randomly. They are calculated from other performance indicators, which are calculated from the data in the databases typically in a hierarchical manner. So for each process area, the indicator, for example, customer satisfaction, will be calculated. This number from 0 to 1 will be calculated based on a lot of data out there. For example, the customer rating that our customers are giving us when contacted by an independent third-party surveying company, or the customer loyalty index, how loyal our customers are. Are they leaving us? Are they staying with us? And our the average amount of time that they are spending in our bank. For example, the lifetime of the customer. So these different data points are then aggregated together to produce a customer satisfaction index. And the customer satisfaction index is the number that you see in the strategic dashboards. So to summarize, there are 3 types of dashboards, of process performance dashboards that you will find in practice. Operational dashboards are for the workers and the operational managers, the people on the ground. Tactical dashboards are for the owners of the process or other business line managers that need to have an overview of how a given process is performing for different types of customers or for different geographies, etc. And the strategic dashboards are for the executive managers who need to have a bird's eye view of what is happening across all the processes of the organization. That having been said, in this course, we are going to focus from a practical perspective on tactical dashboards and on operational dashboards. So in the practice sessions, we are only going to deal with operational dashboards and tactical dashboards. I wanted to make you aware about like the next level, which is the strategic dashboards, because these are things, you know, where, for example, you might be involved in a project that is aimed at providing indexes for a strategic dashboard, or indices, sorry, for a strategic dashboard. But we are not going to be practicing the design of strategic dashboards in a course. Okay, now, how do you design a process performance dashboard, particularly at the operational level and at the tactical level? So I'm offering here a 5-step approach to do that. So, and in the practice session, you will get an exercise along those lines. So you'll be asked to design some performance dashboards. So the first thing you need to do is to identify who is the user, you know, what is the persona behind it? Who is going to be seeing this dashboard? When you design any user-facing element, you need to understand, you need to be able to name the user. And then you need to understand what kind of questions this user is wanting to answer. Once you have like a persona, a user, and a set of questions, you can then try to identify what type of so-called dashboard elements are going to allow them to answer each of their questions. So, for example, you can identify that my user is the loan application, the head of lending at Swedbank. And then you will conduct interviews with them or with the people in their entourage, the business analysts in their entourage, and you will come up with a set of questions that you want to answer by means of a tactical dashboard of the lending process. Maybe you will end up with 5, 6, 7, 10 questions. For each of these questions, you are then going to try to link them to some dashboard elements. So we're going to display a chart that is aimed at answering the question, for example, of how is the process performing in terms of cycle times for different types of customers, gold customers versus regular customers versus private customers, for example. Once you know what dashboard element you need, you know, do you need a chart? Do you need a table? Do you need what type of performance indicators you want to put in the chart or in those tables? Then you have to identify precisely what type of visualization you will use. Specifically, what type of chart do you use? Would you use a bar chart? Would you use a pie chart? Would you use a radar chart, etc.? It all depends, of course, on the type of question that you have. Immediately after, or together with that, you need to then understand what metrics what performance measures are you going to display in this chart? What are you going to display on the x-axis? Are you going to put like the time on the x-axis, or are you going to put different types of countries on the x-axis, or different types of loans on the x-axis? So are you going to put in the x-axis mortgage loans versus car loans versus consumer loans or commercial liability loans, commercial loans, sorry. So what are you going to put on the x-axis? And then what are you going to put on the y-axis? Are you going to put cycle times on the y-axis, or waiting times, or processing times, or costs? What is it that you want to show? What dependencies, relations are you trying to show? So you determine what goes in the x-axis, what goes in the y-axis, and then you have the elements then to give the requirements for designing that chart. There are, as I mentioned, one of the key steps in here is to map, is the step number 2, which is mapping the question you have to a type of dashboard element you want to display to answer that question. In that respect, typical process performance dashboarding tools will provide to you different types of elements. Typical ones are cards, like boxes, that give you some performance indicators, like, for example, the cycle time of the process, the average cycle time, the median cycle time, the maximum cycle time, the minimum cycle time of the process across all cases. Then the tools can give you trend charts. Trend charts are charts where the x-axis is the time. So, for example, January, February, March, April, May, or week 1, week 2, week 3, week 4, or 1st of February, 2nd of February, 3rd of February. So the x-axis denotes dates or months or weeks, for example. And then the y-axis will be used to display some performance measure, like, for example, the number of loan applications that we managed to complete on every month, the number of customer complaints that we received every month of the year. So that is called a trend chart. So you can, because it allows you to see the trends in the data. Are the number of customer complaints increasing, or is this number of customer complaints decreasing? The third type of element that you will find in the performance dashboards, performance dashboarding tools, are distribution charts, performance distribution charts. Here, they are histograms. On the x-axis, you see what is happening. On the x-axis, you see different values of a performance measure, like, for example, less than 2 days, between 2 and 4 days, 4 to 6 days, 9 to 12 days, if I am talking about cycle time. So, and in the y-axis, you see what percentage of cases fall under each of these categories. For example, what percentage of loans have been resolved in less than 2 days? What percentage of loans have been granted in between 2 and 4 days, between 4 and 6 days, or more than 6 days, for example. Another type of element that several tools will offer you are cross-sectional charts. In here, the x-axis, let's call it, will contain different sections of the organization, different countries, or different regions, or different types of products, or different types of customers, like private customers, business customers, gold customers, etc. And on the y-axis, you will have some performance indicator, which could be, for example, the number of loans you have had in each category, or the volume of loans you have had in each of these categories, or the number of loans that have been resolved in less than 5 days versus those that have taken more than 5 days, and so on. And to complement all of these charts, a typical performance dashboarding tool will also allow you to add some tables with some details, like, for example, a table that shows you for every country the number of loans that they have been granted, how many loans have been accepted, how many loans have been rejected, how many loans have been resolved on time, late, how many times customers have complained, etc. So to make this very concrete, I am going to show it to you in a concrete tool, and I'm going to take as input a tool that we have already seen before called Apromore, which we use for process modeling, but that can also be used for performance dashboarding, and as we will see later, can also be used for process mining. So I'm going to move to demo mode. I'm going to take a data set of a repair process. this is a process that starts when you want to get something repaired in the company. For example, let's say that a video projector is not working in a room, or my table telephone is not working, or my computer broke, etc. So you trigger a ticket and you need to get your laptop, for example, fixed as soon as possible. And then there is some technician that will come and examine the problem, and they will try to resolve it and maybe do a couple of interventions. Somebody else might test if it's really working after this intervention. And then sometimes you need to restart the repair and you need to try multiple times. And eventually the case is resolved. You say, okay, case closed, and you archive it. It's like a help desk process in a way. So in a Promore, if I take an event log like this one, you can then go to analyze, and you can see it in a performance dashboard. In the lab session, we will giving you an event log in a CSV format, and you're gonna import it into a Promore. You're gonna see how the event log looks like, and you're gonna do some exercises with it. And this, when you in a Promore, when you select an event log and you go to analyze, view performance dashboard, it opens a default dashboard for that process. So it generates automatically some dashboard with very common performance indicators. I assume I am sharing, yeah? Okay, and what this dashboard shows you, for example, is the number of cases of this process that were active at different points in time. That's what I'm highlighting. For example, on the 4th of January, there were 7 active cases, so 7 requests for repair that were active simultaneously. There was also another peak on the 13th of January and another peak on the 12th of January. Other than that, the number of requests is more or less, active requests is about 5 per day. Here you can see how many task instances, also called events, are executed per day as well. So it gives you an idea of which days there is more volume of work and in which days there is less volume of work. This is another type of chart. These two are trend charts. They show you whether the work is increasing or decreasing, or whether or not the backlog is increasing, decreasing, or is more or less constant. This one here, case duration, this chart is telling you what is the distribution of cycle times of the process. Like, for example, it's telling you that there are 48 cases in this process that are taking between about 0.06 days. That's probably about 3 hours, I think, or no, 0.06 days, probably about 1 hour or so. So there are 48 cases that are taking an hour. There are other cases that are taking more than that or less than that. There are also other charts if you go to the other tabs, because typically a performance dashboard in a performance dashboarding tool has multiple tabs. You can create different tabs to it. So you can go to the activities tab or to the resources tab, and you will get other views of the process. Like, for example, here you have a cross-sectional chart that for every task, analyze defect, register, inform user, test, repair, tells you how many times, in how many cases this task was executed. So for example, here is telling me that the task analyze defect was executed in 1,104 cases, whereas the task repair simple was executed 484 times, and the task repair complex was executed 659 times. So this is like the distribution of activity frequencies. And then similarly in the resources tab, you will see how often different resources in the process were involved in this process. How often was the tester involved? How often was the different solvers involved? These are the technicians in the process. You know, how many times how many repairs did they do, basically? These are default dashboards, but you can customize it. There is a button here called Edit View. let me go to this overview. There is a button called here, Edit View. And once you are in editing mode, you can do whatever you want. You can, for example, delete some of the charts. You can select any of the chart and say, well, I don't want this to be a column chart. I would like it rather to be a line chart or an area chart, for example. I don't want to display the case duration. I would rather want to display the average waiting time for different cases. I wanted to use a percentage relative scale instead of a total scale, et cetera, et cetera. So there are many elements that you can discover by yourself by playing around with the tool that allow you to customize your dashboard. Finish. I'll call that my dashboard. You can construct your own dashboard and save it. And every time you will open that data set, it will, using the performance dashboard plugin, it will show you the performance dashboard that you have designed yourself. Typically, in a company, there will be some analysts slash data scientists who will design this type of dashboards for different users, different operation managers, like the head of lending, the head of the mortgage loan lending team, etc. For each of them, there will be one such dashboard that will be able to, that will give them answers to their most typical questions in a fast manner, so that they can go and look at the dashboard, say on Friday, and look at how we've been performing in the past week, and if necessary, plan some adjustments in the way the process is being executed for the following week. For example, by reallocating some workers from one area of the process to another area of the process. And that's what I wanted to tell you about dashboards, which was meant to be the first half of today's lesson. Performance dashboards are pretty good at gives you an overview of the performance of the process. So I can see, for example, how often I am doing the process in less than 3 days versus more than 3 days. How often I am on, the customer is happy, how often the customer is complaining, etc. So it tells me, it gives me an understanding of where are the problems what type of issues are we experiencing during the execution of a process. And that's very good, because you need to know about the issues. You need to have data about how often different issues are happening in order to decide, to determine if there is a need to adjust a process, to improve a process, or if maybe the process is working very well and we should just leave it there running. However, performance dashboards are not sufficient to tell you what should you do in case there is a problem to fix it. So if we are experiencing delays in a process, you will see it in the performance dashboard. You will see that the number of cases that are taking more than 5 days is very high in one of the charts that I just showed you. But you don't know how can you improve that? How can you address that particular problem? That is the role of that is what process mining, that is the gap that process mining tries to achieve. Process mining is a set of techniques that allows you to use data exactly as the one I showed you before, like the tables I showed you before with the loan application process. You can take those same tables and use them to, in a way, understand in details where are you doing mistakes in the process, where are you spending more time in the process, where are you spending the largest amount of money or cost in your process. So roughly, process mining allows you to do 4 things with an event log. The first thing it allows you to do is something called automated process discovery. And automated process discovery means that from one of these tables that you saw before, we are going to discover a process model automatically. So whereas while in weeks 3 and 4 of this course and in homework number 1, you drew a process model manually by reading some documentation and trying to translate it into a diagram yourself, automated process discovery allows you to discover those process models directly from the data that you have extracted from your enterprise systems. More precisely, from one of the tables which we saw at the beginning of the lecture that contains one event per execution of a task with the case identifier, the task name, and the timestamp, plus other attributes, you can generate different types of models. The simplest type of model that we will see today are called process maps. They are very simple boxes and arrow diagrams, but we will see next week that we can also use the same data to discover BPMN process diagrams from the data. So you don't draw the diagram, you give the data as input, and the process mining tool discovers the process model for you. Of course, the process models that the tool discovers are not necessarily nice looking, and you have to adjust them a bit to make them look good and to be insightful, but they give you, they take all the dependencies in the data and they give them to you in an initial diagram that you can use as a starting point to understand and to discover and to map the process. So as I said, process mining tools usually allow you to discover two types of process models. One is simple ones called process maps, and the other ones are BPMN models. This week, we are going to see process maps, and next week, we are going to see BPMN models as well. A process map, which is also called a directly follows graph, is a boxes and arrows diagram. There are boxes and there are arrows, and that's it. There's nothing more. The boxes, every box represents an activity, a task in the process, recorded in the event log. And every arrow between two boxes represents the fact that in at least one instance of the process, in at least one case of the process, task 1 came immediately before task 2. In more details, for example, here, there is a box here that represents an activity. The name of the activity is called complex repair or repair complex. And below the activity, you will usually have some performance measure. In this case, 659 stands for the number of process instances where we did an execution of this activity. So when the number of instances of the process in which we executed the task repair complex is 659. Every arrow, so there is an activity that is the initial activity in the process, and it's marked, it's recognizable because it has an incoming dotted arc that comes from a little circle that is the start event. That tells you that that activity is an initial activity. In this case, a register is an initial activity because it has an incoming dotted arc coming from the start event. Similarly, an activity is final, meaning it appears at the end of an execution of the process if it has an outgoing dotted arc going to the end event. And an arc in the graph, in the process map, represents the fact that in at least some cases, the task on the left came immediately before the task on the right. In this case, task register was immediately followed in a process instance by the task analyze defect in 1,104 cases or process instances recorded in the event log. From a process map, you can already see how the process unfolds from left to right. you can already see that register is the first activity, that it is always followed by analyze defect. And you can see that archive repair is the last activity in the process. You can see the structure of the process and in particular the loops. For example, here you can see that the activity called inform user is sometimes repeated. Sometimes you do inform user twice. You can also see that there is a short loop from inform user, you go to test repair, and apparently you go back to inform user. That thing is called a short loop. And I'm going to talk a lot about short loops because this week and next week, because short loops sometimes denote repetition, but sometimes they represent parallelism. So you have to be very careful when in a process map you see a short loop. It does not necessarily mean that these two tasks are repeated, as I will show later. In a process map, you will typically overlay some performance measure. And you will ask yourself, why is it that some boxes here are darker than others? Some are light blue and some are dark blue. That is because the colors, the coding or the shade in those boxes is capturing how frequently that activity occurs, specifically in how many process instances it occurs. In other words, on top of the process map per se, I have overlaid a performance measure, which in this case is the case frequency, the number of cases where some activity occurs. But you can change the overlay. In any process mining tool, you can say, instead of displaying the frequency on top of every box in the process map, I want to display the durations, the processing times, or the waiting times, or other attributes like, for example, the cost, etc. Before I show you how that works in the tool, I find it very important to make you understand exactly what a process map stands for, what it means. And the best way of understanding what a process map means is by building one yourself, by drawing one yourself at least once, so that then when you see it in the tool, you understand, okay, this is what it means, and it doesn't mean more than this. So let me take an event log, and let me play the game. Let me simplify, and let me assume that the names of the activities are A, B, C, D, E, F, G. So in other words, I'm using letters to denote the activities instead of giving them full names. And instead of writing the event log as a table, which will take a lot of space, I'm going to write in a very compact manner. I'm going to tell you that there are 5 process instances where activity A is executed first, followed by B, followed by C, G, E, H. So I'm going to draw pen. Here I am saying that there is a number of cases in the process that starts with A, followed by B, followed by C, G, E, H. There are 5 such traces that follow exactly this pathway. In my event log, there are 4 cases that follow this other pathway, A, B, C, but after C, instead of G, I see F, then G, then H. There are 3 cases that follow the pathway A, B, D, G, E, H, and another 3 cases that follow the pathway A, B, D, E, G, H. Almost the same as here, but the G and the E are mixed up. Based on that, I can draw a process map by taking the first pathway in the process and just drawing it linearly. So I'll say activity A is followed 5 times in 5 cases by B, then by C, then by G, then by E, then by H, exactly what I observe here, right? I then take the second process instances and I overlay it on top of it. I say, like, in the second pathway, I see A followed by B. So that's a relation I had already seen before, but now I have seen it 4 more times. This is the number of cases where it happened. So the number of times I have seen it so far is 5 plus 4. I have seen B followed by C, B followed by C. 5 plus 4 equals to 9 times, 5 times here and 4 times here. But after C, in this pathway, I go to F instead of going to G. So instead of adding to this arc, I take another arc and I create an arc from C to F. This means that sometimes F comes immediately after C. Specifically, so far, in 4 cases, F comes after C. Then after F, I see G. Then after G, I see H in these 4 times. So this is the second pathway in a way, this one. Then I go to the third pathway. In the third pathway, I see A followed by B. I had already seen A followed by B. Now I have seen it 3 more times. So I will add plus 3 to the number in this arc. Then I see B followed by D 3 times. D followed by G 3 times. D followed by G 3 times. Then G followed by E 3 times. And then E followed by H 3 times. And if I repeat the same thing for the 4th trace, I will get that I follow this. Then from D, I jump straight to G, E, then to G, and from G, I go to H. So I follow that pathway. And that is, once I add up the numbers, this is the process map corresponding to the event log on the left-hand side of this slide. What does this process map tell you, for example, is that I have seen task B followed immediately by task D in 6 cases, whereas I have seen task D followed immediately by task E in 3 cases. That's what you can get out of the process map. Very important to understand that you should be careful when you interpret a process map in a linear manner, because some of the pathways in the process map do not correspond to traces in real life. So I'm going to show you one. This process map tells me that from A, I can go to B, and that is perfectly true. Then it tells you that from B, you can go to D, and that is also perfectly true. And from D, you can go to G, and that is perfectly true. But then what is more controversial is that it suggests that from G, you can go to E, and that from E, you can go to G, and therefore I can go back to E, and then I can go back to G. And it suggests you that you can repeat this loop multiple times before exiting. But that is not true. If you look at the event log on the left-hand side, there is no repetition of E and G. At no point in time did you see something like E, G, E, G, E, G in the same case, or G, E, G, E, G, E. They don't get repeated. E occurs at most once per case, and G occurs at most once per case. So you have to be a little bit careful when you draw like long pathways in the process map, that there are some pathways in the process map, for example, where you repeat 2 activities that are not present in the original log. So the warning here is process map tells you that directly follows relations between activities. They don't really capture entire pathways. For that, it is better to look at the BPMN model. It's a little bit better to look at the BPMN model, as I will explain in the next lecture. Right. Now, notwithstanding the fact that process maps are sometimes tricky to visualize, to interpret, they are very useful in practice. And one of the reasons why they are very useful is because it is very easy to simplify a process map. For example, by removing the most infrequent edges, the most infrequent arcs in the process map. If I remove them, I can get a much simpler process map. Or I can do something called filtering. I can take the event log and start creating filters over it. And then I can look at a filter view of the event log instead of looking at the full view of the event log. And why is this important, you will tell me? So why is it important that I can simplify a process map so easily? Well, it's very important because real-life event logs, when you look at how it's really executed, when you look at how a process is really being executed, real-life processes are incredibly messy. And this is not just one or two processes. This is 80% of the processes out there are very messy. So here on the left-hand side, I show you the process map of a real-life process for treating patients in a hospital. These are patients for cancers. Not that many patients. Only about 1,150 patients are being shown on the left-hand side. And it's very messy. There is no way you can make sense of that process map. On the right-hand side, I show you another real-life example of something about the way around 300,000 tickets are handled in the help desk of a bank in the Netherlands. So the boxes in that process map corresponds to activities like creating a help desk ticket, or sorry, an incident, an IT incident ticket, investigating, designing a resolution, testing a resolution, escalating a resolution to a software vendor, etc. All those are the activities in the process map, and then you see all the directly follows relations that were observed in that event log. It's very messy. So we definitely need a way to simplify them. And process mining tools, that's one of the things they offer you, is the possibility of adjusting the level of detail of your process map so that you can get something that you can understand, that you can analyze by showing only the most frequent activities and or the most frequent arcs and dropping the most infrequent ones. But you can also do it the other way around, and you can decide that you want to drop the most frequent activities and the most frequent edges, and you want to only focus on the most infrequent ones because you are looking for some anomalies, for example. So I'm going to show you how that looks like in a tool, in a Promore specifically. So I'm going to go back to a Promore, and I'm going to go here, and I'm going to take the repair example, and I'm going to open it in the, I'm just going to double click on an event log. So if I have uploaded an event log into a Promore, I just need to double click on it, and then it opens the process discoverer. What it has done when I double clicked is that it discovered a process map from the event log. This process that I'm showing you here is very simple. To see the full process map, I need to go to these abstraction settings in the center, and I need to push the arcs to 100%. And this is the full process map. It's kind of a little bit messy, as you can see. There are arcs kind of going all over the place. It is a little bit difficult to understand. So I would typically try to move that slider from the right, from 100% down to, let's say, 50% or even less, until I find a level of abstraction that I'm happy with. Well, this is a level of abstraction where I feel like I understand what's going on in this process. I see how it starts. I see how I go to a repair, etc., how I restart the repair, and I do a second simple repair, etc. Beware, what has happened when I moved the slider from right to left is that some arcs were hidden. So you are not seeing the entire process. And that's why, as you can see, there are 1,104 times analyzed defect is being executed, and it is following 528 cases by repair complex. And there are another 570 cases roughly where I don't know what has followed it. If I wanted to know it, I will need to bring in additional details. So in summary, the abstraction sliders allow you to reduce the number of arcs you are visualizing and the number of nodes that you are visualizing. I will show you a more complex example so that you get a better idea of what these sliders are meant for. So I'm going to take an event log of a process for treating patients in a hospital. So these are cancer patients. Cancer patients arrive in the hospital, in the oncology department. First, they arrive to the emergency room usually, and then they are classified within the emergency room. And then depending on their type of cancer, they are further classified. And the ones that I'm seeing in this process are the ones that were diagnosed as having a type of cancer called sepsis. And after that, I do some treatments, IV liquid, IV intravenous liquid treatments, intravenous antibiotics treatments, or I admitted in intensive care or in non-intensive care, lactic acids, etc. So here I have the impression that I am understanding this process, and this goes until we release the patient and they return to the ER, to the emergency room down the road. The real process, however, if I move this arc slider to 100%, I will see the entire process map, and as you can see, it's kind of very messy. These are all that directly follows relations that are observed in these 1,150 patient treatment episodes. And this is not understandable, so I have to bring it to a level of abstraction that is more understandable. And let's say that I want to display only the most frequent activities and the most frequent relations. And then now I have something that is kind of more or less understandable. And then I can start analyzing what's going on in this process, how things are happening. So what can I do with this? I can see the number of cases where ER sepsis triage occurs, 1,050 cases. I can see the number of cases when the emergency room registration happened, etc. I can change the overlay, the statistic that is being displayed. For example, instead of displaying the number of cases where each activity and each directly follows relation happens, I can display the percentage of cases where it happened. So this activity occurs in 100% of the cases in this log, this activity in 100%, this activity in almost 100%, not in all cases. This activity only occurs in 71% of cases. I can see that this activity is the least frequent among those that are being displayed. It occurs in 63% or 64% of cases, roughly. I can display the total number of executions of the task. For example, this activity is executed, let me take this activity, is executed 3,262 times. Note, case frequency tells me in how many cases this activity CRP occurred. It occurred in 1,007 process instances. But in some of these process instances, this activity occurred twice or 3 times or 4 times or 5 times. If I want to know in total, summing across all the cases, how many times CRP was executed, I need to go to this frequency overlay, and I need to change it from case to total. And now I am seeing how many times in total was the activity CRP executed. This is the total workload that this task generated for me. You can also display the average number of times that this activity occurs. So in every case where it occurs, on average, this activity occurs 3.11 times. You can display the maximum amount of times where this activity is executed, meaning there is a case in this process where this activity, CRP, is executed 69 times. If I select max frequency overlay, this number tells me the maximum number of times when activity CRP occurred in a given case. So as surprising as it sounds, there is one case at least, maybe multiple ones, where this activity occurred 69 times, which is enormous. So it means this activity is sometimes repeated a lot of times. And leukocytes, which is another type of treatment, occurs sometimes in up to 74 cases times in the same case, which means there was a patient that underwent the leukocytes treatment 74 times throughout their stay in the hospital. Probably they were undergoing this treatment twice per day for a period of around 35 or 37 days. And that led them to having 74 leukocytes treatments during their stay. And I can also display the minimum number of times when each of these activity occurs. So these two activities, each of them occurs as a minimum once per case. The other activities occurs as a minimum 0 times per case, which means there are cases where they do not occur. So there are cases where this activity was not executed. There are cases where this activity was not executed, and so on. And you can also switch here to the duration overlay. And if you switch to the duration overlay, you can see duration overlay. If you switch to the duration overlay, you can see the average times between two activities. So on average, between the moment ER registration occurs and the moment ER triage occurs, 11 minutes elapse. That's very reassuring. That basically means that people spend around 11 minutes on average in the emergency room registration area. Then they are classified by a nurse, and 3 minutes later, they are classified as being sepsis patients and directed to the correct section of the hospital. So it's pretty nice. It looks that everything is working very well. And then you see IV liquid, IV antibiotics, and you see the waiting times in between. You can also see not only the average waiting times, but the median waiting time. The median is a more robust measure. So here you can see, for example, that the average waiting time between ER triage and ER sepsis triage is 3 minutes, but the median is 25 seconds, which means that in the majority of cases, you just say your name, they retrieve your details, and they tell you, go here. So it takes only a few seconds. But there are some cases where it's taking much more than that. So if I select the maximum duration, there are cases where between the moment you are classified in the emergency room and the moment you are declared to be a sepsis patient, for one patient at least, it took 11 hours between these two events. Well, that's a little bit worrying. That means it's a patient who literally appears to have spent 11 hours in the emergency room waiting to be directed to the right place in the hospital. You can also display the total amount of time that you spend, that across all cases we spent in this transition. So the darker here means that we spend a lot of times between two transitions. So in here, it seems like between the moment I am admitted in intensive care and the moment I undergo leukocytes, it's a very large amount of time. If you add up the amount of time that every patient in this data set spent between these two events, it adds up to around 1.5 years of total waiting time by all the patients. So that's a little bit worrying. That thing you are seeing there is called a bottleneck. That means that there is very long waiting times between two activities, and we need to go on and look at them and tackle them in details. The final thing that I wanted to cover today, at least partially, is the fact that when your process gets pretty large, there is no point in trying to analyze all the cases together. It's better to filter some of the cases. And in that respect, there are a number of filters that a process mining tool will offer you. You can filter by the pathways. You can say, I only want to retain the most frequent pathways in the process and remove the most infrequent ones. You can filter and only retain the data of some of the patients, case IDs, or of some of the loans. Say you want to focus on a small number of loans and see how they evolve over time. You can apply that filter. You can apply also an attribute filter, which allows you, for example, to retain only those cases where a certain activity occurs. So if you want to filter only those cases where an activity occurred, you use an attribute filter. And you can specify conditions over multiple attributes. For example, I might be able to retain only those cases where the activity amend purchase happened, and then that activity was performed by a certain particular worker called Jane, for example. So I can say, give me those cases where amend the purchase order happened and it was performed by Jane, and remove all the other cases. There are also time frame filters that allows you to only retain the cases that happened in a given month or in a given period of time, like all the cases that happen in January and remove all the cases that happen in February or March. Give me all the cases that happened last year and remove all the cases that happened in previous years. So all those questions, you can answer them using time frame filters. And there are other types of filters that we will be seeing, like performance filters, as we go along and in the practice sessions. Just a matter of knowing that these are available. So this process, so it's kind of very interesting here, because what I can see is that the cases where leukocytes and CRP happen are the most interesting cases, because that's where the bottlenecks are happening. So let me say, I want to focus on those cases where leukocytes happen. Note that it doesn't happen in all cases. Leukocytes is only happening in 1,012 cases out of 1,050. So there are some cases where leukocytes is not happening. So if you wanted to focus on those cases where leukocytes is happening, you go here at the top to a little symbol of a filter, and you click on it, and it's going to open the filtering interface. And in here, you can say things like, for example, with an attribute filter, you can say, I want to only retain those cases where the patient underwent a leukocytes treatment. So I apply it, and now I only have those cases, 96% of the cases where this happened. Or perhaps more interesting, you might want to only retain those cases where the activity return to the emergency room happened. That's very important. Those are the cases where the patient left the hospital and had to come back later. And you might want to investigate those cases and to see, well, what kind of patients are coming back. What do we do to those patients that come back that we don't do to the patient come back to the emergency room, that we are not doing to the patients who don't come back to the emergency room? That can help me to learn, how can I improve this process? How can I make sure that people don't have to return to the emergency room? So I go to attributes filter, and I select the activity return ER and nothing else. And then I'll be able to filter only the 28% of cases where people return to the emergency room. And what happens then is I kind of get a simpler process, and I can move my abstraction sliders a little bit higher, maybe not too much, but a little bit higher, and I can observe what happens to those patients that don't return to the emergency room. Note that I can do the opposite as well. Instead of retaining those cases, so here I retain those cases where return ER happened, I can remove those cases where return ER happened, which means I only retain those patients that did not come back to the emergency room, who just stayed home and didn't come back to the emergency room. So I apply, and what do I get? 72% of cases did not return to the ER, and here I am seeing exactly those cases where this returning to the emergency room happened. So what we saw today is performance dashboards, 3 types of dashboards, and a sketch of a method that you can use to design a tactical or an operational dashboard. Then we saw that process mining allows you to take data extracted from a database and discover a process map out of it. And that on top of the process map, we can overlay different types of statistics to understand how the process is performed. Process maps can be very complex, so you will use abstraction sliders to visualize not 100% of the nodes and the arcs in the process map, but just a subset of them. And to be able to dig deeper into some of the cases of this process, you should apply filters. One of the most common types of filters you will be using is the attribute filter that allows you, for example, to retain only those cases where a certain activity occurred, or those cases where a certain activity did not occur. And that allows you to dig deeper into your process and to try to understand how different types of patients, for example, or different types of customers in a bank are being treated throughout the execution of a given process. In the practice session, you are going to have an exercise about performance dashboards first. And then you're going to have an exercise where you will be given an event log of a purchase to pay process. So we give you the log already as a table in CSV format, Excel format, basically. You upload it into a Promore, and you will start analyzing it yourself and answering certain questions. For example, about what is the difference in execution times between the cases where some mistake happened and those cases where that mistake does not happen. So apply filters to be able to compare different types of cases. If there are any questions,